In this lesson, we are going to be going over limits of accuracy and typical questions that you will find in a GCSE exam. Now, before we start, there are some prerequisites that you need to know. First of all, you need to be able to round to decimal places, significant figures, so on and so forth. We'll be going over a few examples quickly, and then later on in this lesson, we are going to be going over actual GCSE questions. So let's begin, let's start. So typically you'll be given a value, and you might be told that, for example, here 12 meters has been rounded to the nearest meter. And you are expected to find the error interval. Now, what we have been told is that 12 meters has been rounded to the nearest meter. So the first thing that we are going to start off by looking at is putting 12 on some sort of number line. Okay, now because it has been rounded to the nearest meter, we will write down on either side of 12 the next values. Okay, so for example, you have 13 meters here, and before that you have 11 meters. And then what we will do is go halfway between these 2 points, and we will write down what is actually halfway. So between 11 and 12, we have 11.5, and between 12 and 13, we have 12.5. So those are the lowest values and the highest values that our answer could have been. So what do I mean by that? For example, 12 could have been 11.5, 11.6, 11.7, 11.8, 11.9 on this side, on the lower limits, and on the other limits, on the upper limits, sorry, it could have been 12.1, 12.2, 12.3, and 12.4. We're just going to stop here briefly. Okay, so if we now go back to all of these values on the left hand side, the 11.5, 11.6, so on and so forth, and I said to you that can you round these values to the nearest meter? You will obviously round every single one of these. 11.5 to 12, you round 11.6 to 12, 11.7 to 12, 11.8 to 12, and 11.9 to 12, because that value here after the decimal place is 5 or more, and therefore that means when it comes to rounding, we round up. On the other side, we have 12.1, 12.2, 12.3, and 12.4. Now, it's very interesting. This 12.4, we could have added lots and lots of nines. It doesn't matter how many nines we add, we could continue this on. But we will notice that if you were asked to round this to the nearest meter, you will always round to 12, because that value right here is less than 5, and as a result we round down. Now this answer in its entirety is practically 12.5. So what we write instead is, let me just change the color here, we'll write 12 and we'll use these signs. So this is the less than sign, and we'll say that 12 is less than 12.5. And on the other side, we'll write greater than or equal to, and we'll write down 11.5, which are these values. Now, why we don't write an equal to sign here is because our value for 12 that has been rounded to the nearest meter to become 12 isn't exactly 12.5. It is 12.499999, and that's why we write down a less than sign only for this one. We write down this less than sign only. So if you understood this, we will go on to a few more examples, and this is basically it. This is how you find the upper and lower bound, with this becoming the lower bound and this being our upper bound. Okay, so let's move on to the next example. Okay, so example number 2, we are told that 655 kilograms has been rounded to the nearest kilogram. Okay, so once again, we'll put 655 on our number line. And what is after 655? The next kilogram. It is 656. And before that, it is 654. So once again, what we'll do now is look for the halfway points. And in between 654 and 655, we have 654.5. And here we have between 655 and 656, we have 655.5. So what, just like before, what we write down now is less than on this side, greater than or equal to on this side, and we just write down these two values. So here we'll have 655.5 and here we'll have 654.5, and that is our error interval. Okay, and an easy exam question would be to write it in this format and leave your answer like that. All right, so let's move on to another question. Okay, so example number 3, and what do we have here? We have £320 has been rounded to the nearest £10. So we want to find what the minimum value of £320 has been rounded from and the maximum value that it has been rounded down to. Okay, so 320 on our number line here. So 300 and because it's been to the nearest 10, we'll add 10 on this side. So that gives us 300. Oops, sorry. That gives us 330. And on the other side, we have 310. So once again, we find the center. And between 310 and 320, we have £315. And on this other side, for the upper bound, we have 325. So once again, we write down our symbols, just like that. And here we'll add 325 and 315. And this becomes our answer, with this side here being our lower bound or our lower limit, and this side here being our upper bound or upper limit. So I hope you've understood that. We'll move on to one final example, hoping that you get the hang of this, and then we'll look at some exam questions. Okay, so in this example, 12.5 centimeters has been rounded to the nearest millimeter. Now you've got to be very careful here. I've chosen this one deliberately because we have centimeters, but we have been told that this answer has actually been rounded to the nearest millimeter. So before we begin, what we are going to do is convert 12.5 centimeters into millimeters. We know that in 1 centimeter, we have 10 millimeters. So we can multiply this answer by 10, giving us 125 millimeters. And then after that, we will do exactly the same thing as we have been doing previously. So to the nearest millimeter, the next millimeter up will be 126 millimeters, and the one before that will be 124 millimeters. And then what we'll do is we'll go in the middle between the two, and we'll write down what's halfway in between. So we have 124.5 and we have 125.5. Now our answer is in millimeters, so what we'll now do is convert back to centimeters by dividing by 10. So our answer will be 12.5 centimeters. I'll just scroll down here so you can see. So 12.5 centimeters less than, and on the other side we'll write greater than or equal to, and we'll write down these two values. So for our upper limit, we'll have 12.55 and 12.45. Remember, we've had to divide by 10 again so that we can have it back into our centimeters. So this becomes our final answer, our error interval.